Within the Internet, an autonomous system is a collection of connected Internet Protocol routing prefixes under the control of one or more network operators that presents a common, clearly defined routing policy to the Internet. Originally, the definition required control by a single entity, typically an Internet service provider or a very large organization with independent connections to multiple networks, that adhere to a single and clearly defined routing policy, as originally defined in RFC 1771. The newer definition in RFC 1930 came into use because multiple organizations can run BGP using private AS numbers to an ISP that connects all those organizations to the Internet. Even though there may be multiple autonomous systems supported by the ISP, the Internet only sees the routing policy of the ISP. That ISP must have an officially registered autonomous system number. A unique ASN is allocated to each AS for use in BGP routing. AS numbers are important because the ASN uniquely identifies each network on the Internet. Until 2007, AS numbers were defined as 16-bit integers, which allowed for a maximum of 65,536 assignments. RFC 4893 introduced 32-bit AS numbers, which Internet Assigned Numbers Authority to regional Internet registries have begun to allocate, although this proposed standard has now been replaced by RFC 6793. These numbers are written preferably as simple integers ranging from 0 to 4,294,967,295, or in the form called ASDOT, which looks like XY, where X and Y are 16-bit numbers. Numbers of the form 0Y are exactly the old 16-bit AS numbers. The accepted textual representation of autonomous system numbers is defined in RFC 5396 as ASPLAIN. The special 16-bit ASN 23456 was assigned by IANA as a placeholder for 32-bit ASN values for the case when 32-bit ASN-capable routers send BGP messages to routers with older BGP software which do not understand the new 32-bit ASNs. The first and last ASNs of the original 16-bit integers, namely 0 and 65,535. And the last ASN of the 32-bit numbers, namely 4,294,967,295 are reserved and should not be used by operators. ASNs 64,512 to 65,534 of the original 16-bit AS range, and 4,200,000,000 to 4,294,967,294 of the 32-bit range are reserved for private use by RFC 6996, meaning they can be used internally but should not be announced to the global Internet. All other ASNs are subject to assignment by IANA. The number of unique autonomous networks in the routing system of the Internet exceeded 5,000 in 1999, 30,000 in late 2008, 35,000 in mid-2010, 42,000 in late 2012, and 47,000 in mid-2014. Assignment: AS numbers are assigned in blocks by the Internet Assigned Numbers Authority to regional Internet registries. The appropriate RIR then assigns AS numbers to entities within its designated area from the block assigned by the IANA. Entities wishing to receive an ASN must complete the application process of their local RIR and be approved before being assigned an ASN. Current IANA ASN assignments to RIRs can be found on the IANA website. Types: autonomous systems can be grouped into three categories, depending on their connectivity and operating policy. A multi-owned autonomous system is an AS that maintains connections to more than one other AS. This allows the AS to remain connected to the Internet in the event of a complete failure of one of their connections. However, this type of AS would not allow traffic from one AS to pass through on its way to another AS. A stub autonomous system refers to an AS that is connected to only one other AS. This may be an apparent waste of an AS number if the network's routing policy is the same as its upstream ASs. However, the stub AS may in fact have peering with other autonomous systems that is not reflected in public route view servers. Specific examples include private interconnections in the financial and transportation sectors. A transit autonomous system is an AS that provides connections through itself to other networks. That is, Network A can use Network B, the transit AS, to connect to Network C. If one AS is an ISPs for another, then the former is a transit AS. See also, Routing Assets Database, INOCDBA, a hotline communication system between the network operation centers of major autonomous systems, administrative distance, references. External links, ASN Resource Guide, CIDR and ASN Assignment Report update continuously, Exploring Autonomous System Numbers, ASN Searching and Tracing by Fixed Orbit, a shunt, an AS Tracer route utility, Autonomous System Hose Lookup, What is my ASN, Why Autonomous Systems.